So, I'm here to talk about a project that I have the opportunity to collaborate with, and this is a new project. So what I'm going to show is what the project is going to be, more than what is it, and what are the principles, the goal, and the motivations, and just a few snapshots of the starting of the works within this project. The project is named Freewat, and the major aims of this project, that is an Horizon 2020 European project, is to develop some tools integrated in GIS environment to promote the water resource management, simplifying the application of the water framework directives and the groundwater directives and other water related directives. So basically the idea is that the European Union has developed some water directives that should be put in place, and we would like to develop some tools that help this application in real cases. The idea of using open source as a platform to build up this application is because we would like to have an ad includendum approach, so that further institution, further research could add new extensions, new functionalities, and somehow we want to grow up a community behind this that can help to grow these projects, also behind the hand of the project itself. What Freewat expects to achieve is to help the governments and peoples and stakeholders to take relevant decisions based on some tools that enables the analysis of the data, and also we will try to include participatory approach, not only in the discussion of the results, but also while setting up the models and the analysis part. So the key aims of this project is are the key aims of the water framework directives. So European community in this framework pose the accent on the willing to expanding the scope of water protections to all waters, including surface and groundwaters together. They try to achieve a good status of the resource, and to manage the waters based on river basins, watersheds, and to use a combined approach between limit values and quality standards, and also putting the right price for using out of the water. So this is one key aspect that I found also in other projects, that European Union wants that the user pays the resource, such that people can understand the values of the resource. Because as long as it is free, many people don't understand and are not forced to make a wise use of the resource. And then the directive aims at involve more closely the citizen and instreaming the legislation. The concept and the motivations that are behind this project. So we want to develop ICT tools to boost the application of water framework directives, as I said. We want to train technical staff and authorities and private companies to use the state-of-the-art innovative software for water management. So there will be a quite important part of training and teaching within this project. Then we want to have some tools that are free and open source, numerically based and GIS integrated, so that we can perform a spatial and temporal analysis of water quantity and quality issues. Then We would like to enable the user also to make analysis in conjunctive between surface and groundwater. So coupling existing model, generally you have models for subsurface or subsurface water or for lakes, and we would like to couple everything so that the user can run and make some simulation, keeping in mind all the water cycle, let's say. We want to provide something that is spatially distributed and time series driven. We want to give the opportunity to the user to using the data provided by extensive monitorings in doing these studies. We want to contribute to the capacity building in Europe, and I say the participatory approach early and then the result, and then transfer also some scientific findings to the real scale application so that the user can take real advantages of this. So basically we want to coordinate some previous efforts and results of projects, support the participatory approach, promote the water management. I say that we are going to transfer this technology, running a lot of training courses, knowledge transfer, etc. And we are going to include in our project more than 200 stakeholders. And you can see that these stakeholders come from really different type of institution, from research, basin authority, environmental protection agency, national authorities, local government, etc. And also from different area of interest, from water quality, policies, contaminations. Who is Freewat? Is coordinated by the Scuola Superiore Sant'Anna di Pisa as a steering group with TEA Sistemi, TU Darmstadt, Germany, and CSIC, Spain, that are the main investigators, let's say. And then there are 13 case studies. So in the first part there will be the development of all the systems, then it is going to be applied in 13 case studies to explore and to evaluate everything, and to keep in consideration the stakeholder engagement and needs. My institution is now a collaborating institute within these projects, and this is the consortium. Where do we start from? Existing tools, existing project that did something is Seed and Grid. It was a project from Regione Lombarda, that Regione Toscana, sorry, that put together surface water, groundwater flow in saturated zone processes. Marsol FP7 project, solute transport in the groundwater. Quimet, Catalan Water Agency, developed a GIS-based hydrogeochemical analysis tool. Nitratos project, European. Best practice in management of mineral organic fertilizer while reducing the nitrite pollution. And FEDER 13 France, 3D database, namely PostGIS 3D. Latest project is the porting of Seed and Grid into QGIS project. So what's new in Freewat? We are going to add new modules for water management and planning, tool for observation data analysis, tools for calibration, uncertainty and sensitivity analysis, solute transport in the unsaturated zone, lake water interactions, crop growth and water requirement in agriculture, tools for dealing with groundwater quality issues, tools for the analysis, interpretation and visualization of hydrogeological data. The selected environment is QGIS. So with the support also of Oslandia, we are going to develop everything as an add-on in QGIS. And here are some of the first results the project is really new, so there are just a few screenshots of the first implementations. So you can create a new model, you can select some layers and data, and then you can run your models. That is basically based on ModFlow, this one. And you can make some analysis and extrapolate some images of the water table under steady state or withdrawal, to understand, for example, the importance of the water extraction, the consequence. The other tools, and here I'm talking more about what we will be involved in, is the observation analysis tool for UCode. UCode is a model from USGS that is used for calibrations of models, and basically it take the model design, run the models, take out the output and compare the output with the data and try to the best fit and calibrate the parameters of the models. In this operation, the data are very important because a correct preparation of data and analysis of tools will allow us to better focus the calibration. So for instance, if you are more interested in having some model that is good in simulating extreme events, you can put more weight on observation on extreme weather respect to normal cases. So the model fit better in your case of needs. This model will encompass some analysis of raw data, some like regularization, data interpolation, fitting, filling, decomposition of filtering of time series, aggregation and exit sans time calculation, and some hydrological indexes. And then this model will prepare the output already for the UCode, the calibration module, so that in the interface you don't have to deal anymore. Nowadays, you mostly have to deal with text file preparation input for setting the models, for calibrating and everything. So we want to make the life easier for modelers. Okay, we can skip this part. Is about the importance of data into the calibration. You can see that some data may contain more information than others. So if you have different sensors in the fields, some sensors are more important for the fittings and the modelings than others. So it is important to detect which are the most the data that contain more information for the models. And these are some examples. So the first idea of modeling this data within the GIS is take somehow the inspiration of our experiences in using sensor observation services. So we took some of the elements, but we try to keep it really light and really focused on this type. So the data will be simulated are like points with data associated. Points will have some information regarding metadata of the sensor so that we can understand better how these data are. And the library that we are going to build up is around this observation analysis tool object to build up some readers and then some exporter to the models, and then having the ability to store this data locally into spatial light, because from Oslandia, spatial light would be the repository where to store all the result of the models and the input and everything. And then we want to apply some processes that we don't want to override the original object by creating a new object with processed data. So then you can select and decide to store the new object and override the original, etc. Just a few codes. Up to now we can create new object, specifying parameters, and then we can load values to this. Basically we create a sensor and then we upload the data. For instance from CSV, or from ISOS, you can directly create the object from sensor observation services and upload the data from a sensor observation services locally. Then you can, for instance, resample these time series or save to spatial light, loading back, and then you can plot, for instance, having the data original every 10 minutes or resampled every hours. This is just the first step into the project, let's say. The other part that we are going to take care of is the integration of the lake package. Lake package is an extension, let's say, of ModFlow, and allows to simulate the interaction between surface water, groundwaters, and lake waters. So you can understand, for instance, what we want to do and study in Switzerland is how, in case of chemical dangers or contamination, does this contamination reach the lake? When? How do civil protection have to manage this fact and the populations? How do they have to react? And for doing this, we are going to include these packages, and this is one example that shows how the water exchange between groundwater and the lake is happening. Sometimes the laking is giving water to the groundwater, sometimes on the way back. There is another part that is going to be implemented from the Spain partners that are related to the database for hydrogeological characterizations. They already did it into proprietary software, and they are going to translate this technology into QGIS to having this within the project. As I said, this is just a presentation of what the project will be. I'm sure that the next year I will propose a presentation with some more results, and thank you very much.